Good morning. Welcome to day 2 of week 1 of BPE Super Summer Science Academy, grade 7 and 8. Super exciting day. Um, First thing I want to do is I want to go through major changes to our Bitmoji classroom. Um, so I want to make sure that you all know what we're talking about when we say click on this, click on that, yada yada. Okay, so first things first, let me get over here to our classroom. Hold on. Okay, now, first thing is, let me put it, make it bigger, bigger. There it is. Ain't it beautiful? Okay, so you already know what this is. The link isn't in there, but by the time the link is in there, you'll know what it is because you will have clicked on it to watch this video. That's so weird, I know. Okay, so we still have our little love poster. It doesn't have anything linked to it yet. We still have our multiplication tables, and I hope that you are doing that. Right here, this is for RTI meetings that they're going to be having, and I want to make sure that you understand this, Tuesday and Thursday at 10 o'clock. So today, because it's Tuesday, day 2, week 1, at 10 o'clock, if it's not later than that because you guys have slept in, you're going to go ahead and click on here and you're going to go to whatever it is that RTI has in store for you. Okay? Okay. And of course, we still have our Zoom meeting and our, oops, where'd he go? Our guinea pig is down there, but our little bars, well, anyway. Okay, so over here, this is our schedule, Wednesday and Friday at 2 o'clock p.m. So Wednesday, tomorrow, you're going to be doing a Zoom experiment online with Mrs. Ramos. She's going to be doing some stuff about water filtration and teaching you about that. And then on Friday, you're going to be meeting back with her at 2 o'clock to do some reflection on what you learned. This right here is an online Scholastic book fair. So do not forget to visit that because we all know that Scholastic has the best deals on the best books. So go there and do that. And anything that is raised will benefit BPE. So you want to do that. Okay, click on here. I'm going to be talking a little bit about the Inventors Contest today, maybe some possibilities of what you might want to be thinking about when it comes to applying your brain power to inventing. This right here, this speaker, if you click on that speaker, it'll take you to a YouTube video of this week's announcements given by Mrs. Tovar. Yeah, you want to do that every week. Up here, we'll take you to Go Math. This one right here is the new PG&E icon that will take you to a survey. And what you should do is have your parent or guardian do the survey, because what that will do is it will help PG&E, and in return, PG&E will help you with some really cool sciencey electricity stuff. And who couldn't use that? I could. Okay, right here are little thingies that spell science. They're Scrabble tiles. I think it's so cute. But each one of these is going to take you to a separate video. That's Mr. Tovar. Okay, so each one of those letters is going to have a different video done by Mr. Tovar. You don't want to miss out on that because he has a lot of fun with his videos and you'll learn something. And who couldn't stand to learn something else? Okay, so this right here is a link to a story that is going to be read by, I think, Magenta Howard. This right here is a link. Will take you to a craft project by, who is it? By Miss Vanessa. And this book right here is a story, Miss Ellie's Read Aloud. And this spoon right here is Miss Garcia will make some Kool-Aid ice cream, which is really awesome, especially since it's going to get hot. real soon, and you're going to want some of that. These books right here are will take you to Ms. Tracy's Read Aloud. Awesome. That's just an aquarium. It doesn't take you anywhere except to look at the cool fishes. Eventually, but not yet, this will take you to, what will take it to you? To Mr. Sanders' VAPA lessons and Zooms. And this will, not yet, but it will take you to Ms. Renzo's art lessons and Zooms. And this right here will take you to the continuation of Mr. Oscar reading The Hobbit. You guys that were in my class actually have a copy of The Hobbit. I started reading it, and then I got sick, and then I couldn't do it because then I got too busy. But good news, Mr. Oscar is reading it, and you guys can catch up with it. And those of you that weren't in my class, the 8th graders, it's cool just to sit and listen to it anyway. It's one of the coolest stories ever written. Ask Mr. Tarbell. Okay, so this right here will lead you to videos for PE and working out and stuff, which is really, really cool. So I think this gets us through all of what's up here. And lots of links, lots of great things to visit and do. And then I am going to actually show you another video. So let me stop share this thing right here. And I am going to, now I'm going to tell you right now that this particular video is really, really weird. It's like this blue blobby thing with a mustache on it that has hands. And I think it was made in India, but I don't know for sure. But it has a lot of information that I think that you can learn from. Lots of stuff about how water, many different ways water can become contaminated and what it might do to you if you do get contaminated. And so I want you to pay attention. There's one part in there where it's talking about how if you get water that has bacteria in it that is, causes really bad stomach issues, where these little cartoon children in the far background are kind of throwing up a little bit. Just close your eyes. Just close your eyes. But it's good. It's informative. This is why I'm not going to show that video. I'm going to show a TED Talk instead. Maybe if you're lucky, if you ask real nice, I'll show you a clip of that other video by the end of the week because it was fascinating. I learned a lot, but it was weird. Okay, well, this is a TED Talk, so I'm going to go ahead and show that to you. Let me. Okay. Oh, shoot. I'm going to unshare. Share again. Share computer sound. There we go. Unshare. Stop share. Sorry. Okay, there we go. All right. Here we go.
Take a look at the water in this glass. Refreshing, hydrating, and invaluable to your survival. Before you take a sip, though, how do you know that the water inside is free from disease-causing organisms and pollutants? 1 out of 10 people in the world can't actually be sure that their water is clean and safe to drink. Why is that? Inadequate sanitation, poor protection of drinking water sources, and improper hygiene often lead to sewage and feces contaminated water. That's the ideal breeding ground for dangerous bacteria, viruses, and parasites. And the effects of these pathogens are staggering. Diarrheal disease from unsafe water is one of the leading causes of death around the world for children under 5. And according to a UN report from 2010, microbial waterborne illnesses killed more people per year than war. Proper treatment processes, though, can address these threats. They usually have 3 parts: sedimentation, filtration, and disinfection. Once water has been collected in a treatment facility, it's ready for cleaning. The first step, sedimentation, just takes time. The water sits undisturbed, allowing heavier particles to sink to the bottom. Often, though, particles are just too small to be removed by sedimentation alone and need to be filtered. Gravity pulls the water downward through layers of sand that catch leftover particles in their pores, prepping the water for its final treatment, a dose of disinfectant. Chemicals, primarily forms of chlorine and ozone, are mixed in to kill off any pathogens and to disinfect pipes and storage systems. Chlorine is highly effective in destroying water's living organisms, but its use remains government regulated because it has potentially harmful chemical byproducts. And if an imbalance of chlorine occurs during the disinfection process, it can trigger other chemical reactions. For example, levels of chlorine byproducts like trihalomethanes could skyrocket, leading to pipe corrosion and the release of iron, copper, and lead into drinking water. Water contamination from these and other sources, including leaching, chemical spills, and runoffs, has been linked to long-term health effects like cancer, cardiovascular and neurological diseases, and miscarriage. Unfortunately, analyzing the exact risks of chemically contaminated water is difficult. So while it's clear that disinfectants make us safer by removing disease-causing pathogens, experts have yet to determine the full scope of how the chemical cocktail in our drinking water really impacts human health. So how can you tell whether the water you have access to, whether from a tap or otherwise, is drinkable? Firstly, too much turbidity, trace organic compounds, or high-density heavy metals like arsenic, chromium, or lead mean that the water is unsuitable for consumption. A lot of contaminants, like lead or arsenic, won't be obvious without tests, but some clues, like cloudiness, brown or yellow coloration, a foul odor, or an excessive chlorine smell, can indicate the need to investigate further. Water testing kits can go a step further and confirm the presence of many different contaminants and chemicals. With many types of contamination, there are ways of treating water where it's used instead of close to its source. Point-of-use treatment has actually been around for thousands of years. Ancient Egyptians boiled away many organic contaminants with the sun's heat. And in ancient Greece, Hippocrates designed a bag that trapped bad-tasting sediments from water. Today, point-of-use processes usually involve ionization to lower mineral content. They also use adsorption filtration, where a porous material called activated carbon strains the water to remove contaminants and chemical byproducts. While it's not always an effective long-term solution, point-of-use treatment is portable, easy to install, and adaptable. And in regions where large-scale systems are unavailable, or where water has been contaminated further along its journey, these systems can mean the difference between life and death. Clean water remains a precious and often scarce commodity. There are nearly 800 million of us who still don't have regular access to it. The good news is that continued developments in water treatment, both on a large and small scale, can alleviate a lot of unsafe conditions. Implementing proper systems where they're needed and paying careful attention to the ones already in place will fulfill one of the most basic of our human needs.
That was awesome. Oops, hold on. Okay, so now you can see all the different ways that water can actually be contaminated. And sometimes it's very organic. I mean, sometimes it's just that on a waterway, a bear has caught a salmon, eaten most of it, but left the rest of it to decay on the side of the riverbank, and parts of that decay have fallen into the river. Or sometimes maybe a cow goes into a waterway somewhere along, like a canal or a river or a stream or something, to get water, and maybe does his business in the waterway. It happens, and sometimes that's what contaminates the water. It's not always human stuff, although humans do actually do a lot more harm than good, generally speaking. I wanted to show you another clip of a video, and this is a guy that works in a wastewater treatment plant, because I wanted to show you about the fact that he is an inventor there. Now, they've already invented the process for treating wastewater. What he's trying to do is invent ways that make it better, faster, more efficient, less expensive, and leave less of a carbon footprint on our planet. So even though something has been invented, doesn't mean that it can't be invented to be better than it is now. So I want you to keep that in your mind. Think about something that is already there, but you think, if only it did this too. Think about it. I want to show this to you real quick. Okay.
Wastewater is one part of the human water cycle, which describes the many ways people interact with nature's hydrologic cycle to meet our needs for water, food, and energy. While water treatment plants are a necessary part of public health and environmental safety, they require a great deal of energy and resources to operate.
In the US, we devote about 3 to 6% of the national energy budget on the enterprise of clean water.
Kartik Chandran is a professor of Earth and Environmental Engineering at Columbia University and funded by the National Science Foundation. He investigates new, more efficient ways to treat wastewater. Wastewater contains elements such as phosphorus, organic carbon, and nitrogen, which are often removed during the treatment process.
Well, let's start with nitrogen. When we want to remove nitrogen from wastewater, in addition to the organic carbon, the energy footprint of a wastewater treatment plant essentially doubles.
At the Newtown Wastewater Treatment Plant in Brooklyn, New York, treating wastewater involves several steps. First, the system separates floating matter and solids from the water. The remaining sewage then enters an aeration tank.
What we do in aeration tanks is we supply oxygen to microorganisms that actually treat the sewage.
Typical microbes for wastewater treatment require oxygen to degrade organic pollutants. The resulting sludge is further treated, and in its final step, the water is disinfected. Chandran is trying to reduce the amount of energy used in this process. He uses a type of bacteria found in wastewater called anammox. These organisms don't need oxygen to remove nitrogen from wastewater. While traditional wastewater treatment often releases greenhouse gases such as nitrous oxide and carbon dioxide, using anammox bacteria does not.
They allow us to remove nitrogen at far lower energy costs and chemical costs. Not just that, we would save 60% in terms of aeration costs if we use the anammox model for removing nitrogen.
Chandran and his team are also looking at ways to use wastewater's abundant chemicals, nutrients, and other resources to produce energy.
We have been able to convert the organic carbon in food waste, in sewage sludge, in fecal sludge to biodiesel, which is a liquid fuel easily transported and easily used, directly used in diesel engines.
The Newtown Wastewater Treatment Plant is already producing energy from organic material.
The digesters are heated to about 95 degrees Fahrenheit. They act like the human body. They break down the organic material, and we provide no oxygen. And one of the byproducts of the digestion process is methane gas.
Methane gas is a common energy source.
We are right now using a good portion of our digester gas to heat our boilers in our locations. The boilers are used for heating the environmental areas, the personnel areas, and they're also used to reheat the digesters.
Chandran and his team are also finding additional uses for wastewater products. For example, they are using the organic carbon found in wastewater to develop bioplastics and taking the phosphorus and nitrogen from wastewater for use in irrigation.
By linking the water sector, the energy sector, the food sector, and a few other sectors, we are now able to address these challenges not just one by one, individually in isolation, but together in conjunction. That's a very sustainable model.
As Chandran and his team help make the human water cycle more energy efficient, they are also helping us see wastewater not as waste, but as a precious resource.
Okay. All right, so hold on a sec. Close these down. So I just wanted to point that out to you because I wanted you to know that even though things have already been invented, does not mean that that's the end of it. It's done. We're done. Um, a little story I want to tell you. When I was a kid, I used to love to roller skate, and this was way before there were inline skates. And I used to dream as a, like daydream. You know how kids do. I used to daydream that I was ice skating because I loved to ice skate and I wanted to be an ice skater. And I thought, well, wouldn't it be cool? Wouldn't it be cool if somebody invented a roller skate that had the rollers all in one line, like ice skates were? If I hadn't been 8 years old, I would have been rich today. Let me tell you that. Anything that can be invented to be better. Ralph Waldo Emerson had a phrase that said, build a better mousetrap and the world will beat a path to your door, meaning that no invention is done. We can always do things better, more efficiently, more cost effective, more healthy, more everything. Things can be done to make things better. So I want you to understand that as an inventor, don't think that any idea is too goofy or too small or too big or too anything. If you think that it can be better and make things better for you, then do it. That's what invention is all about. All right. You have a great day, and we will see you later.